Hello everyone and welcome to another lesson of Principal e-Business. Now, some of you could be surprised. I'm actually opening starting off with a console application, but in this lesson I wanted to cover with you some of the major concepts that you're gonna rely on once you get working outside of the faculty, once you graduate one day, or working on your seminars or your graduation projects. Um, the idea here is some of us, when we were working with management information systems seminars and everything, we some of you got already into trouble with some of the queries where you have to tweak some of the filters even more in a bit professional way. So people tend to make a lot of queries, repetitive queries, if you will, for different types of classes, where they could make one generic query and it will apply to everything, or one generic filter and it will apply to everything. Um, in this lesson, I'm gonna review with you delegates. I'm gonna start completely from the beginning, from the basics. What are delegates and why they are useful, and then we're gonna end up to lambdas, which most people have trouble. Some of you have trouble understanding it. In fact, I'm gonna supply this. Um, I'm gonna supply actually with this video tutorial a PDF file summarizing or highlighting the major points which I'm gonna discuss over here in this video. And my advice: watch the video first and then read the PDF, so they will be complementary. Or I don't know. I mean, I didn't start writing it yet, so. But in general, my advice to you is just watch the video, read the PDF, and then in case you run into any troubles, feel free to post on the forums, and I will be glad to help you out. All right. First of all, some of you could be noticing I have a little bit different kind of Visual Studio. I mean, this darkish line over here. Um, I don't know, this darkish kind of a theme. I got this from Tools Extension Manager, and if you this is actually the installed ones. I advise you to get this one, Productivity Power Tools. It is really amazing piece of add-in. It's really excellent thing. You could install it, you could have fun with it. I mean, I'm gonna use a couple keyboard shortcut keys here. I'm gonna show you the ones which I mostly use. A spell checker, which is quite obvious, and as you can see here, it's just checks the spelling of your comments and everything. And then something for fun I actually put for myself is like edit theme editor, where you can actually start switching your themes from here. So basically, when I install the power tools, you have something like the solution, their own solution navigator. They supplied it to you, so you can like navigate inside your classes like this and have a complete hierarchy of all your functions and everything. Even if you go, for example, to system, and then you could expand it, I don't know, to other things, all the classes which you have in here. So it's really cool, and of course includes the search here, which you can search for your whatever variables or functions you want to search for. It is really great piece. And in fact, here are a couple of keyboard shortcut keys that you could be seeing most of the time. So for example, if I create an lst equal to new list of integers, let's say, if I put one bracket, it completes it right away, and if I hit shift enter, it makes the semicolon, goes to the next line. And for example, if I have an int I equals to 0 and another, for example, float j equals to 1 or 10, whatever, I could with the alt key, if I hold down the alt key and if I hit the up arrow, I could just move the lines wherever I go. So it will be much easier, like instead of um, cut and paste it somewhere, like cut and then find and paste. It's easier, much easier to move the whole thing. So multiple lines as well works. All right. Now let me get rid of this. Now back on the subject. Now, what are delegates? Delegate is essentially a function pointer. like in C++. That's pretty much it. A delegate, this is for people who are working with C++. A delegate, if somebody asks you, a delegate is actually a type. And a type is anything, of course, you can make a variable out of. A delegate, you can assign to it a function. You can put a function inside a variable and then pass that variable as a parameter of another function. So let's see what I'm talking about here. Now, mostly, I had big troubles understanding why I would use delegates from books, because books they usually need really huge examples in order to really describe that. I mean, and then they describe they say the delegates, how do they work in a very simple example like the ones which I'm going to show you here. And then in order for you to understand delegate, they just push the events part where you can use delegates and events, and they show you how important the delegates are. But in fact, delegates are very powerful things, or powerful feature in C# that you actually don't need only events to see it how it's working. In fact, you can get it to work in a very different way. I mean, okay, let's see what I'm talking about. Let me show you what I'm talking about here. So I would have a delegate here. So a delegate is a type, so I'm declaring the type. So it's like when you say integer or when you say float. So it is pretty much the same thing. A delegate is just a simple type you create a variable out of. Now, once you create a delegate, you have to write in the function signature. So is your function which you're going to stuff inside that variable, is it going to be a void function? Is it going to be a function that returns a string? Is it going to be a function that returns a float or an integer? That's a question is up to you. For now, I will keep it simple, and I will say that the function is a void function, and the name of the type, I'm going to call it my delegate, and that's it. Somehow the shift enter didn't work out for now. So right now I created my own just type, just that delegate, and that's it. Now if I come here into the class program, I'm gonna create a static void print something, and in here I'm gonna just say console.writeLine, and in here I'm gonna just say something, because I mean this is the name of the function, print something. And let me see here. Of course I created it a static function because I don't want to create a new object of the program class, so I would love to access it right away, like print something, so in the void main function. And let me see here. So I would love to stuff that function inside that variable, so and then start using it. So I could say my delegate, let's say it's gonna be called del, and then I'm gonna pass in here print something, and that's pretty much it. Right now this variable contains this function. Now please make sure that the signature of this function matches the signature of that guy. If this is void, then this guy has to be void. If this thing takes parameters, then this guy has to be having as well a parameter. So if this happens to be a string, then this guy has to be a string. Okay? If this didn't happen, if I hit, let's say, Control-Shift-B, okay, apart from this one doesn't return anything, string reviewing delegates program.print something has the wrong return type, you see? So this guy has the wrong return type because right now I'm trying to stuff in a function that doesn't match the signature. So of course you have to keep it void. And the same analogy for if this is accept an integer variable, then this thing has to accept an integer variable. You can, I mean, the names here are not important. I mean, the name of the variable is not important as long as the type is correct. So if here is integer, here has to be integer. The name doesn't matter, but the main thing that you have to have a complete matching signature. Alright, so let me delete that once I describe the part about the signature. And let's see how we can use that thing. So if I come here I will say a static. Right now here it doesn't matter. The function here, signature doesn't matter. Doesn't have any connection with this. If I say do something, and let's see over here, and it takes, yes, and I would love to have, it takes my delegate as a parameter. So, and here I'm just gonna say delegate with this deleg dot invoke. So what happens is I'm gonna pass in here a function. So I'm gonna say del, oh no, sorry, do something, and here I'm gonna pass the deleg, and that's pretty much it. Now what's gonna happen here is instead of calling this function directly, I'm stuffing that function inside the variable, passing it here inside do something. Do something will take this variable, comes into here. Delegate.invoke, it will just see the invoke part, it will see what kind of function did I have in here, and it will simply invoke that function. So it jumps here and invokes that function. If you want to, we could try to debug this thing. So let me see. So F5. Oh no, why? Oh, hold on a second. Let me just check that thing. Let me see. Probably I made a mistake somewhere. Oh, sorry. It's del. Yeah. Okay. So let me put back here the thing. So by the way, this is my console here, so it's not important. Now I will keep pressing F11. So right now I stopped the function inside the variable. Now I'm jumping in here. Now of course once I do that function call, it sees the parameter passed in here. It right now is going to try to invoke it, and then the next step is just trying to print that something. So once it's done, it comes back into here, and that's it. So you get something presented on, I mean output comes out on the screen. So this is basically it. This is all about the delegates. I mean, in their simplest form. Now, most of people will be saying, why not doing this? I mean, I could do that right away. Why I have to go in circles, stuff a function inside a variable, pass it as a parameter inside another function, and then recall it back again? Somehow most of the books which I read, they failed to mention that, and I really run into troubles. I mean, asking other, I mean, friends and other people who are really into these stuff, and mostly they give me those, I mean, simple examples about calculators and everything, which is exactly quite nice. I get it from the first time, of course, and everything, they are clear, but somehow they didn't get, I didn't get the point until now of them. I mean, I still not using them. But once, let me show you another example where you can really utilize delegates and see their full power. So let's say I'm gonna have a function. I'm gonna keep actually the same examples which I shown people in the same classes. So I'm gonna take a static, and then I'm gonna return a list of integers. So a static function that returns a list of integer, and I would love to find all the numbers that are less than 5. In here I would love to pass an input, so list integer, and I'm gonna call here an input. So basically what I'm gonna do, the user is gonna create a list, and then create a list of integers, and then he will find, and then this function has to find all the numbers that are less than 5. So I have to go and create a temporarily list, or we can call it like lst var, lst equals to list int, and, or I'm gonna call it again result, sorry about that, result, and I'm gonna have to for each var item in my input, and I'm gonna say if item is less than 5, then please add that item to the result. Am I missing something here? Add result. Okay. Somehow the IntelliSense didn't want to work out. And at the end, return result. So this is what is happening. Let me delete. I'll print something here. It takes a little bit of space. Okay. In here I'm gonna. Oh, before I go further, because some of you could be seeing vars and they will say, okay, you are using it only with queries. Why are you using it right now? There's a big difference between. I mean, no big difference actually. There's no difference. There's a way of two ways of declaring variables in C#. One is the explicit typing and one is the implicit typing. Explicit typing, which means that if I create an int I equals to 0. Implicit typing, when I say var j or the same var I equals to 0, of course I have to get an error because I'm declaring the same. I mean I could put j here. So this is the same as that one. The only thing what happens is the compiler in the compile time sees what variable has how the variable has been initialized. If it is initialized to integer, you see it right away, it's an int. If I put this 1.50, this is gonna be automatically a double. If I put here f, this guy became a float. So this is how C# handles it. So instead of you typing, I'm gonna create a new list of integers, I don't know, equals to new da da da. So you could write simply, because people who are working in C#, they saw everything just redundant. So they just say, anyway, when you're gonna initialize it, I mean the compiler is gonna be smart enough to understand that once you create an integer here, it means that you are creating an integer list. If you made this as a float, it's immediately gonna be a float, and it's gonna be less typing for you and less hustle if on renaming if you're gonna have to rename something. And it is the same thing goes into here. So var item, now as you can see here, item should be, well, doesn't want to say somewhat. Yeah, here you go. So item should be actually an integer. So this is gonna, so right now it's an int 32, which means that this one is an integer. Of course, if I rename all this to a float, this guy is gonna be a float. So right now I'm gonna go and say I'm gonna create my input. So var lst or var lst my input equals to new list of integers, and here I'm gonna say my input dot add, and then I'm gonna add, let's say 1, and I'm gonna copy paste this several times, not like that. So, and here I'm gonna keep this simple, so yeah, 10, 20, 3, let's say 4 and 2. There we go. And then I'm gonna just simply call that function. Let's say so I'm gonna have var result equals to less than 5, and then in here I'm gonna pass in my input, and then I'm just gonna simply for each item in my result, and then I'm gonna just say console.writeLine writeLine item. Now this is a very simple example. Most of you already saw it in the early courses of programming. Okay, let me just try to decrease the space here to fit in as much as possible. Okay, now if I start without debugging, and it won't because probably I made a mistake in here. Oh, sorry, I forgot the new keyword. Oh, why nobody tells me about it? Okay, there we go. Control 5. Again, let me say, cannot convert from int to int. Oh boy, item. Sorry about that, guys. Control F5 again, and here you go. So 1, 3, 4, and 2. So I have added. So right now all the numbers that are less than 5 has been added over here. Okay, so since I have the results are publicated correctly, now what if I would like to create a new, let's say, function that for example find numbers that are less than 10 or more than 1000. Now in fact I have to start writing the functions over and over again for each number that I would like um, to filter against. Alright, some of the people said, okay, why not passing, instead of creating another function every time, why not passing here a number? So I could say int checker. So instead of here, I'm just gonna pass here a checker, and inside my function I will say please compare it against 5 or against 6, whatever. So if I hit Control F5, it will work out the same. I mean, it will work out well. But the problem is, this is quite cool. Yes, it would work in this situation, but what happens if you cannot access the code? I mean, even in Link, when you are typing your queries, when you are typing, for example, the where clause, you don't actually access the where clause code inside Link in order for you to pass in inside the if statement, for example, or inside the to tap inside the for each loop. So you cannot actually do that. What if this function contents were closed and you cannot access them? Now the programmer who provided for you the function, he has to make it quite flexible, that you could right now tap inside that function and start modifying your own and putting your own conditions. So delegates are so powerful that you can actually do that. So your question here is, what if I would like to modify this code, this line, without touching anything here? So I will not touch inside the function. I would like to modify only this statement. So right now we have to pass a delegate inside. So let me show you how this would work. So I'm going to create a delegate, and since this guy, this part, since the if statement is a Boolean operation, so I mean, if you check if the item is less than 5, so it is mostly a true or false operation. So it's a Boolean operation. So right now I have to create a function that once I put it in here, it has to return to me a Boolean thing. So I will put here bool, and I'm gonna put here a predicate. I'm gonna call it predicate. You can call it whatever you want. So it's not the name is not important. And I'm gonna pass in here a parameter which is called I'm gonna call it number. Okay, so okay, semicolon. Now that means that whatever function you're gonna create, in order to filter these guys, to filter this guy at least, or the list which you are passing, it has to have a returning type which is Boolean, and it has to have an integer variable which you're going to compare against. I mean, you have to say less than what? Less than 5, more than 10, whatever. So you have really to pass a function that has a meaningful, like this one, that has the same signature as this one. So additional parameter I have to add in here. I'm gonna put here a predicate checker for now. Let it be. And in here I'm gonna put checker dot invoke, and in between braces here I'm gonna put here item. So what's happening is I'm passing this item as a parameter inside my function, and I'm checking it again, I'm checking against it if it is less or more, it is less or more than 5, whatever. So I'm gonna have to pass a function here right away. Let me make this out for you. So after the main, I'm gonna create a static bool check if less than 5, and in here I'm gonna put here an integer whatever variable. I don't want to keep the names the same so you will not confuse. You say it has to be the same name, so I'm just keeping different names so you can see that the names really doesn't matter in here. I'm gonna return if I'm gonna turn here if the variable is less than 5. So this is a Boolean operation. If this variable is less than 5, it will return true, otherwise it will return false. So actually basically this is it. So in here, this function signature, it has to be modified right now. So this function signature. So right now I have to pass another parameter, and it takes a predicate, which is a checker. Now a predicate checker, or the delegate, which I'm passing in here, has these following signature: Boolean. It has to have, if you want to stuff in a function as a parameter for that delegate, I mean, it has to have return type Boolean, and it has to have at least one function parameter which is an integer. Okay, so let me see, this guy matches it. So this function returns a bool, and it has an integer variable or integer parameter. So I can pass in here, let me copy this, paste it over here. So check if less than 5 will be valid, because it matches the signature of my delegate. Now if I hit Control F5, it would be working back again. So 1, 3, 4, 2. Now the coolest thing about it, I will not touch here the function anymore. I will just simply say larger than 5. So I get 10 and 20. Now as you can see the power of it, you don't need actually to tap inside the function or pass it as course as a parameter. I mean, you can of course pass here the number as a parameter, but I'm talking about here in case that you don't have access to this part as you are working in with link queries and link extension methods. Okay, so this is basically it about how delegates, why delegates are important, because right now you can tap inside, break into a certain process, and then put your own thing, and then let the compiler do the rest for you. So basically you could find me doing, so I mean basically you can imagine that this function, for now, Control C that, you can imagine that this function is actually being here. So inside that if statement, imagine it, just imagine it, just this function has been stuffed inside that if statement. Okay, this is what happened inside the compile time. Okay, I would love actually to keep this lesson, I'm gonna keep it actually a little bit short, so I will try to post like part 1, part 2, and part 3. So I will continue upon this, building upon this topic in the next lesson. See you in the next lesson.